So yesterday we saw the sort by higher order function. I mean, most of the higher order function we saw, like we saw uh, map higher order function, filter higher order function, then we saw a for each higher order function, then we saw uh, reduce higher order function, then we saw a fold higher order function, and we also just discussed on fold left and fold right. I mean, those use cases, I think I will try to show it when we go to Spark. Most of them we will see the use case there. Here we know how it works, but the use cases will be shown in the Spark here. And along with that, we also saw our sort by higher order function. Sort by higher order function is nothing but a higher order function which takes one more function, and you can write any logic here, and based on what is the return value of this function, the sorting will be done. So here as you can see, we are returning the size of the string. So it will be sorting based on the size of the string here. So yesterday there was a question saying that how do we sort it in the descending order? Any luck on how to sort it in the descending order? To sort it in the descending order, I mean there is nothing like already available built in something. So you have to just say you have to redefine your function. The function that you are writing. So instead of size, you have to return the negative value of size. So size of red will be 3 now. Instead of 3, it will be minus 3. This will be minus 4. This will be minus 5, and this will be minus 6. Since minus 6 comes first, yellow will be the first element. Oh, voice is low. Okay, okay. So we have to just make it as a negative sign. So we'll get the sorting done. So colors dot sort by, and I just say get size. Since the size is negative, we are using a it is sorted in the descending order. That's how you use a sort by higher order function. So we can also use the function literals. We know that we can directly use the function literal. So yes dot, we just say underscore is each element underscore dot size will give the size of that element, and the sorting will be done on the size of the element. So if you want to sort it in the descending order, we just have to say a negative sign it will sort in the descending order. So I hope this was clear here. So there is one higher order function remaining, that is nothing but flatMap. FlatMap is the one higher order function remaining. After that, we'll move on to the Spark, and the new concepts that come around Scala will be explained with respect to the Spark context. Map we did. filter, for each, reduce, fold, sort by. These are all different higher order functions. Other higher order functions are also available. I mean, I also haven't used those things, but whichever is important, I am showcasing those. Similarly, there is one more called as flatMap. Just like we have a map, we also have a flat map. It also works on a collection. Flat map also takes a function called it is also a higher order function, takes a function and takes the same type as the collection type, and again it returns some other type. Finally, it will return the collection. It is almost the same as map higher order function. It works on a collection of type A and returns a collection of type B. It is almost same as I mean to say the map higher order function. Then what is the difference here? Internal difference is slightly. We will see the what is how the internally map and flat map works. To understand that, let's take a example. So let's have a list called. So this is a simple collection. This is a simple list with only two elements. This is our first element. This is our second element. There are two elements in the collection, but if you see, each element is internally comma separated. Each element internally has two different words, and those words are comma separated. Black is one word, coffee is one word, milk is one word, tea is one word. Now the idea here is the idea here is to get the result as all the words as separate elements of a collection. Finally, we should have black as one element, coffee as the second element, milk as the third element, and tea as the fourth element. So totally there should be four elements in our list. So how can we do this? So we can do this. One thing is we know that in Java there is a split method. So on a string there is a split method available. So if I split it by comma, it will split this string into an array. We know that in Java that is a common method. So as you can see here, this complete string has been splitted into two words, black and coffee, as a separate elements of an array. So this will be helpful for us. Now we have done it for a single element. Now if you want to do it for every element of the collection, I want to transform every element of the collection. Obviously I will be using a map higher order function. So on this list, I will use the map higher order function and pass a function literal, take each element, and split it by comma. Whatever logic I have given here, that logic will be applied on every element. This is one element I showed. Every element will do a split by comma. So we got slightly different thing here. So what we have got here is each element is a array now, because split returns an array, because split returns a array. We don't want such kind of a thing. What we want is we want black as one element, coffee as one element. So we just say after that we can do a flatten. Flatten, what it will do is it will unnest the nested structure. What we have here is a list of array of string. So instead of list of array of string, I want only the list of string. So it will unnest the nested structure. Flatten is all about that, unnesting the nested structure. So as you can see, now we have black, coffee, milk, and tea as four separate elements. So that's the map and flatten. So instead of doing map and flatten, we can directly do flat map. So flat map is all about flattening, doing the transformation, and flattening the transformation, unnesting the nested structure. That's the idea of flat map. So I hope the flat map was clear here. When we do a flat map, the number of elements in the destination collection may be equal to or more than the source collection. Here there were two elements, here there were two elements, here we have more than two elements. But in case of map higher order function, the number of elements in the source collection will be always equal to the number of elements in the destination collection. In flat map it could be more. It could be more because we will be flattening it, we'll be unnesting the nested structure, hence it will have more fields. So that's the idea of flat map. So keeping these things in mind, I think all these things should be good enough to move on to the Spark here. But first we'll see the theory behind the Spark, a slight theory behind the Spark, and then we will go and look into the examples. So any questions still here on Scala? Okay. So if there are no questions, then we'll move on to the Spark part here. Now, just like we said, we answered the question why Scala, why Scala is required, and in a similar fashion we'll answer the question why Spark. So there are two important reasons why Spark is required. The very first important reason is Spark acts as a single platform. Spark is a framework. This framework acts as a single platform for different kinds of data processing. Now, what do we mean by different kinds of data processing? We will see that. We will see that. And one more reason why Spark is required is Spark is in-memory processing framework. So these are the two main reasons why Spark is being used in the industry nowadays. Now let's see what is the first reason. A Spark framework acts as a single platform for different kinds of data processing. Now we know that in the Hadoop ecosystem means the base of the Hadoop ecosystem is HDFS and YAR. This is the base. When anybody says they have installed Hadoop means these are the any new releases comes in a Hadoop means these two will be modified. These are the base of Hadoop. Now HDFS is used to store the data. Yarn is used to schedule your processes or manage your CPU cores and RAM. Now there has to be applications which has to process the data. We have the data in our HDFS. We have to write applications so that we can process the data. So I said that MapReduce is a framework which helps us to write applications which can read the data from HDFS and start processing the data. And I also said that during the introduction that the APIs that are exposed with MapReduce are Java, Python, C, C++. You can use the traditional languages to write programs, write applications using MapReduce framework. Now that is not a flex. There is not much flexibility here. Every engineer or every software engineer has to now learn Java or traditional languages for data processing. Usually the data processing comes under the data warehousing. We know that. Data warehousing can maximize their productivity if they use Hadoop. Hadoop is can or I can say that Hadoop can be used in the data warehousing because there also we deal with the data. So if Hadoop is being used in data warehousing, all the engineers in the data warehousing they have to start learning the traditional languages so that they can implement MapReduce application, which is not a feasible solution because most of the data warehousing engineers are SQL experts. Now they have to learn the traditional languages. They have to try to change their mindset most for these things. So which is not a feasible solution. As a result, we know that Hive was introduced. Hive is just a interface framework. Hive is just an interface framework. It is not a database which gives the end user an interface to write SQL kind of queries, which will be finally transformed into a MapReduce application by this Hive framework, and those MapReduce applications will be running on your cluster. So that's the feasible solution. Now the data warehousing team they need not learn any new additional languages. They can make use of the Hive framework and start giving the queries which they are comfortable with. In a similar fashion, sometimes we have to do ETL processing in your data warehousing. Now the ETL engineers also need to learn Java, Python or C++ if they want to have Hadoop for their ETL processing, which is also not a feasible solution. To solve that problem, Pig framework was introduced. Again, Pig framework is just an interface on top of MapReduce, which gives the end user an interface to write a scripting kind of a language. not the traditional languages, a scripting kind of a language which they are usually comfortable with. And that script will be converted into a MapReduce application, and finally it will be run on the Hadoop cluster. So as you can see here, to achieve the same processing, you just want to process your data. Your data exists in HDFS, and you just want to process your data. We are making use of three different frameworks. Now each framework will itself will have hundreds of thousands of lines of code. So you have to start maintaining the multiple frameworks. Similarly, as you can see here now, what these MapReduce, Hive, and Pig will do is your data already exists in HDFS. Probably you have uh, one one day data, or you have 1 week's data, or you have last 1 month data, and so on. It could be lot of data. So your data already exists there. It's kind of a static data. On that you are doing the processing. So it is kind of a batch processing. It's a batch processing thing. Now suppose you want to do a streaming here. Batch processing in the sense you have your data, static data, and you are processing your static data. Now, now you want to do real-time processing, or you do stream processing. Now real time means immediately as soon as you receive your data, you process and give back the result. But in this case, if you take 1 day's data, actually you are waiting for 1 day. Only after 1 day you are giving the result back. If you are processing 1 week's data, indirectly it means that you are waiting for 1 week, and only after 1 week you are giving the result. And same thing holds good for 1 month again. You will be waiting for 1 month, only then you will be giving back the result. What if we want the result immediately as soon as we receive the data? So for that, stream processing is required. You have to process the data immediately, and earlier no framework existed in the Hadoop ecosystem. So a different framework existed called as Storm. So one more framework has to be integrated with your Hadoop framework, so that you can achieve real-time processing. And Storm is not part of Hadoop. It is an independent streaming framework. Now one more framework came into picture. In a similar fashion, let's say you want to do some machine learning. You want to predict what will be the sales next month based on your sales data for the last 4 years or something like that. Let's say you have last 4 years sales data, and you want to predict what will be the next month sales based on that data. Obviously, machine learning algorithms will be used here. So for machine learning algorithms, again, one more framework existed, which was based on MapReduce, Mahout. In a similar fashion, there is one more framework called Giraffe, which is used for graph processing. I haven't worked on this. I did not work on this, but this framework is all about representing your data in the form of vertices and edges. So once you represent your data in the form of vertices and edges, it is kind of a graph. Now there are algorithms on the graph that could be run to process the data, and Giraffe is all about that. So as you can see here, multiple frameworks are required to If at all you are developing an end-to-end pipeline, so most of the frameworks will be required. Most of the frameworks will be required, but all these frameworks are having hundreds of thousands of lines of code. All these frameworks are not bug free. All these frameworks are not directly suited for your business application. You have to change some code, you have to enhance something, you have to add few things, you have to, in general, what I am trying to say here is you have to maintain all these frameworks. More the lines of code, more the bugs will be there. More the bugs, more the resources are required to handle all these frameworks. So instead of having this, what if we have a single framework? What if we have a single framework which can handle all these things? So that's what Spark is all about. Spark is all about that. Just one framework which can achieve all the things that is available here. So it is kind of a replacement for MapReduce. It is kind of a replacement for MapReduce, and instead of Hive, you have Spark SQL. Spark SQL library is there. Instead of Storm, you have streaming libraries there. Uh, Pig Pig instead of Pig, you can write the Spark code itself. It's not a direct replacement, but indirectly we can do the ETL processes can be also handled with the Spark. Instead of Mahout, you have Spark ML. Instead of Giraffe, we have GraphX. Now instead of maintaining those many frameworks, each framework is hundreds of thousands of lines of code. Instead of that, we are having only one framework. We have drastically reduced the number of lines of code, and everything is available as a library here now. So if you want to achieve an end-to-end pipeline, most of the stuffs will be solved by Spark itself. Most of the stuffs will be solved by Spark. So that's the number one reason why Spark is being used, because instead of maintaining lot of frameworks, we have to now just maintain only one framework. So that's the first point. Spark framework acts as a single platform for different kinds of data processing. Now, what do I mean by different kinds of data processing? This is a batch processing. This is streaming processing, real-time processing. This is machine learning. This is graph processing. So as you can see, these are all our different kinds of data processing. Batch processing, ETL processing, stream processing. Here again, batch processing can again subdivided as SQL processing. Pig can be subdivided as ETL processing. So these are our different kinds of data processing. SQL processing, ETL processing, stream processing, machine learning, graph processing. So all these things are available in a single platform. So that's the reason companies go for Spark. This is the one reason. Now the other reason is Spark is in-memory processing framework. Now what do we mean by in-memory processing framework? The name is a bit confusing here because everything is in-memory processing only. Any application you take, everything happens in the memory itself. Nothing happens on the disk. The whole processing happens in the memory. Here, in-memory processing means even after the processing is done, you can retain the data in the memory. That's what they mean by in-memory processing here. The MapReduce framework that was there earlier, I mean, still it is just deprecated now. So MapReduce can only read the data from the disk. It can read the data from disk, do some processing here. After processing the data, it will again save the data back to the disk. Again, if it wants to do some more processing, we know that MapReduce reads the data and and saves the data back to the disk. Same way, some more processing you want to do, again you do some more processing and save the data back to the disk here. So that's how the MapReduce works. Every time it touches the disk, and there is a disk latency here. There is a disk latency. Now Spark is slightly different. Here I'm talking about Spark as a in-memory processing. Spark has the ability to read from the disk. Spark also has the ability to read from the memory. After reading, it will do some processing just like MapReduce can do the processing. Spark application can also do the processing. After processing the data, it can retain the data in the memory. It need not save it back. That's I mean it need not drop it into the disk. It can still retain the data in the memory. Again, if you want to do some more processing, it can get the data from that memory itself, do some more processing, and then save the data or retain the data back in the memory. Again, if it wants to do some more processing, it can do some more processing just by reading the data from the memory, and final result can be stored back to the disk. So you are having your data in memory itself. So which makes your processing much faster. As compared to MapReduce, it will be much faster. So it is the matrix says that if if MapReduce is x times faster, Spark is 10x to 100x faster. 100x is the ideal condition, but it will range from 10x to 100x faster than MapReduce. So now what we have here, we have a single framework, which is a lean framework now, because instead of handling multiple frameworks, we are having only one framework, and that framework can handle a lot of functionalities, different kinds of processings, and again it is faster. A smaller framework and a faster framework and does a lot of different kinds of processing. So obviously companies will go for such kind of a framework. So I hope the main reason why Spark is nowadays in demand is clear. This is the main two reason why Spark is in demand. So any questions still here? Now keeping this in mind, we know that now Spark is a framework. Now every framework will have a data structure associated with it, or we can say an abstraction in your framework that should be used by a developer. A data structure. The best way to say is every framework will have a data structure which the developers has to use and represent the data. So the data structure of Spark is nothing but RDD. Now what is RDD here? As we will expand the name here, RDD means resilient, distributed, dataset. Now here dataset means what? So here dataset is a name given for just a collection. RD is just a collection, that's all. Just like we have a list collection, RDD is also a collection. Just like we have this list collection, RDD is also a collection, that's all. The difference here is if I take a list, if I say nums is equal to list of 4, 5, 6, 7. If I say var RDD nums equal to of 4, 5, 6, 7. This is not the syntax to create an RDD. Just keep in mind that we don't use this syntax to create. There does not exist any syntax to create an RDD like this. It is just to give a comparison, that's all. Just like we have a list collection, we have a RDD collection. Only thing is this collection is distributed. Now when we create a collection list, this list is created in this laptop. It is not distributed, it is available in the memory of this laptop. But when we create a RDD, this RDD is distributed across the nodes in the cluster. The memory of the nodes of the cluster. So that's what it means distributed. So 4, 5 may be in one system, 6 could be in another system, system 2, 7 could be in another system. Here system is nothing but a node. in the cluster. So this is a distributed collection. The data is divided and distributed. Data is divided and distributed across the memory of the nodes of the cluster. Now it is resilient. Now what do we mean by resilient here? Here resilient means the literal meaning is nothing but tolerant. Resilient is we are tolerant to something. We are resilient to something. We are tolerant to something. Here Spark is resilient to what? Spark is resilient to what? As we know that Spark internal data structure is a RDD. So whenever you read the data from the disk, internally it will be represented as a collection, which is a RDD. After processing that collection, you will retain that collection inside the memory itself. I mean that collection is distributed and stored across the system. It is divided and distributed across the system here. Now we know that one of the system, a node in a system, a node in a cluster can always go down. Means the data in the memory will be lost because we are retaining the data in the memory. So it is possible that if at all a node goes down, the data in the memory will be lost. So even if the data is lost, Spark can recover from that. Spark has a as resilient to data loss. So we will see that later. How it is resilient to data loss, that requires lot of other understanding. But just to give a brief on RDD, RD means resilient, which is tolerant. It is tolerant to data loss. Because of in-memory processing, the data will be retained in the memory. So if a node goes down, the data in the memory will be lost. So even if the data in the memory is lost, it can recover from that. It is tolerant to data loss. So that's what we mean by RDD. So in a simple terms, RDD is just a collection. That's all. You process the elements of the collection. Here also you process the elements of the RDD collection. There you store normal items. Here you can store the complete records. Just like you can imagine, we have a table. What is a table? Table is again a collection of records. So RDD is also just a collection of records, nothing else. So along with here is a question. The question is, uh, can we control the RDD distribution across the cluster? So you mean to say which part of the data goes to which node? Yes, we can control. We can control that. I mean, we indirectly we can control that which data goes to which system. We can control, but we cannot say that uh, exactly which system. I mean to say, uh, So you have a collection. Just say you have a collection of what we said: user 1, user 2, user 3, user 4, and so on. If you remember, user 1 was a tuple, user 2 was a tuple, user 3 was a tuple, user 4 was a tuple. So we had these tuples. So you can think RDD is also a collection of those tuples. Now I want all the records with the same city to go in one place. All the users from Bangalore should be in system 1. All the users from from Chennai city should be in system 2. All the users, I mean not system 2. So you cannot say that which record goes to which system, but we can control that all the records with Bangalore city, all the users with Bangalore city will go to one system. But which system we cannot control. System 1 we have, system 2, system 3, and one more is system 5. System 4. Now we cannot say that all the records, all the users with Bangalore city should go to system 1. We cannot control that. We can control that all the users with Bangalore city can go to some system. So that system could be system 1, system 2, system 3, or system 4, but we can control that it will have all the users with Bangalore city. So that we can control. So I hope, Naveen, that was clear. Again, we'll see that later. With example, we will see that. So as I said, RDD is nothing but a simple collection, that's all, which is just divided and distributed, and even if the data is lost, it can recover from that data loss. So these are the primary things about the RDD. Along with that, there are some other properties associated with the RDD. What is that? This collection is again immutable. When I say this collection is immutable, you cannot modify the contents of this collection. Just like we did our map transformation, we did a filter transformation, we did a reduce transformation, we did a for each, not for each, we did a sort transformations, everything we did. So if you see that all those transformations just returned a new collection, the original collection was never modified. The same thing holds good for Spark RDD also. RDD is also immutable collection. You cannot modify this immutable collection. And just like we called map higher order function, filter higher order function, and all other higher order function on normal collection, in the same way we can call the all those higher order functions on our RDD collections. There is no difference at all. Again, it will return a new collection. It takes a input as a collection and it returns a new collection. So that's what we mean by it is immutable collection here. This is one property, and we know the importance of immutability. We know the importance of immutability is all about making your code much safer. Again, we have one more property associated with this, which is nothing but lazy. The operations that we do on a collection RDD, on this RDD collection, are lazy operations. I mean, certain operations are lazy here. So what do we mean by lazy here? So whenever we did a transformation, Whenever we called flatMap, whenever we call the map higher order function on this collection, immediately this code was evaluated. Immediately this code was evaluated, the flatMap. So when we say lazy, the code will not be evaluated immediately. So that's the difference between lazy and non-lazy. Most of the languages are, I mean, the the jargon they use is strict and lazy. Languages are either strict or lazy. Most of the languages are strict. So strict means as soon as the code gets executed, it gets evaluated immediately. Then and there it is evaluated. So if you take C, C++, Java, Scala, or many other programming languages, all are by default strict. Immediately everything gets evaluated. There are few languages which are lazy. It will not evaluate the code immediately as soon as it is executed. So the languages like Haskell, so they are lazy, meaning they will be not evaluated immediately, so it will be evaluated later. The idea here is, I mean, there are use cases of being lazy, multiple use cases of being lazy. Use cases like you you write multiple lines of code, none of them gets evaluated. It will be evaluated only when you ask for the result. When you ask for the result. Ask for result. That's what we mean by lazy. So when you actually evaluate, you will be evaluating all the expressions. Some you have line 1 code, line 2 code, you have line 3. All these are code. This is our code. So if it is a lazy code, if it is a lazy code, it will be none of them will be evaluated immediately. It will be evaluated only when you ask for the result. The idea here is when you evaluate it, you can do some optimization here. During evaluation, do some optimization. Internally, the compiler will do some optimization. That's the idea of using the lazy thing here. So that is one of the use case of being lazy. One of the use case of being lazy. Sometimes we can have val, some object you are creating, which internally takes a object called user user object. Now there is a new user object. New user has to be created first, then that user will be sent here. Now sometimes due to multi-threading or something, some concurrency programming, so what happens here is you can, this code may get executed first. This code gets executed first before this code could execute. I'm just taking a hypothetical thing here. Before this code executed first. Obviously, it will throw a null pointer exception. It will throw a null pointer exception. So instead of that, if you make this as a lazy expression, let's make it as lazy. Now this lazy will be evaluated only when you access it, when you ask for the result, or only when you access it. Now we are accessing it in the user repository. We are passing as a constructor parameter to our user repository class. So it will be called now. As soon as it is being accessed, the object will be created now. So there will be no null pointer exception kind of a stuff. That is one more use case of being lazy. There are many other use cases of being lazy here. So one of the good use case is you don't have to. I mean to say, while actually processing the data, you can do some optimization. You don't immediately process it, you process it later when you actually ask for the result, and while processing it, you can do some optimization. That is one of the use case, and Spark makes use of that use case with respect to RDD here. So I hope the lazy was clear. What do we mean by lazy is clear. In Scala we have Scala is also a strict Scala is also strict, but it uses a lazy keyword sometimes to make the language, to make the expressions lazy. Scala is by default strict. Haskell is strict, lazy always. Haskell is always lazy. Scala is by default strict. Immediately it evaluates. It evaluates immediately, but it also has the capability to be lazy. So the way it is lazy is it uses a keyword called lazy here. Let me showcase you with an example. So as I said, all these documents are available in my Google Drive in the Scala folder with respect to Scala. All these things are available in my Scala folder in the Google Drive training folder. So we talked about higher order functions. All these higher order functions are available. So I will showcase one example. I will define a random point. I will say val x is equal to. So I have just defined a class. I have just defined a class here, and those class, and I mean to say this class has X and Y as the members. X is the member of the class and Y is also member of the class. To these members, we are assigning some random values. Just we are assigning some random values. In Scala, there is always a default constructor. The compiler the compiler always creates a default constructor. And what is the body of that constructor? In Scala, there is default constructor. So body of the constructor is nothing but is all expression in the class. All expressions in the class except method definition. Except method definition is the everything becomes the body of the class. What I'm trying to say here is if I say class ABC, so I say val x equal to 10, val y is equal to 20, and I will say define get x, define get y. So I will just say print ln, something like this. So what are all the method definition here? Get x and get y are the methods of this class. Except for this, any expression you write, any expression that is in the class, it will be the body of the constructor. So your constructor is nothing but val x equal to 10. Internally it will be something like that. Internally there will be a constructor something like this. This is your constructor. There will be a constructor method inside your class which will be defined in this fashion. So whenever you create a new object, we know that the constructor will be called and these expressions will be evaluated. These expressions will be evaluated, and same thing holds good here. Here val x equal to random init and val y is equal to this init. So these two will be part of the constructor, meaning these two expressions gets evaluated as soon as you create a object. If I create an object called random point 1 saying new random point, so we create a new random point, we can access random point dot x. It will have some random value. Y also, if you access, it will also have some random value. So I hope this is clear that internally in a Scala there will be the Scala compiler will always create a primary constructor, and the body of that primary constructor will be all the expressions in the class except method definition. Everything will be the body of the constructor, and we know that the constructor gets evaluated as soon as we create the object of that class. Now just to clarify this, that we are saying whatever I said is correct, we'll put some prints here just to verify that whatever I have said is correct. We will try to put some prints. So here itself we can put the print. And we can separate that by a semicolon. If you are writing multiple expressions on the same line, so you have to have a semicolon. Multiple expressions on the same line. Similarly, we can do it for both. Just to verify these things that everything is correct. So if I say val random point 1 is equal to new random point, what we are having here, as I said, we are getting that prints. So it verifies that these two are part of the constructor. This anything that we write except the method definitions are part of our construct. This gets verified. Now our idea is to understand lazy. How Scala supports lazy. So to understand that, what we'll make is we'll make one of the identifier or one of the member as lazy. So this is how you make an expression lazy in Scala by using the lazy keyword. By using the lazy keyword. Now we know that these two are part of the constructor and both must get evaluated as soon as we create an object. But now we have made one of the member as lazy. Let's see whether it gets evaluated as soon as it is executed. Val random point is equal to new random point. So as you can see here now, this time only we are getting creating X. Even though both were part of the constructor, even though both got executed, only this got evaluated because it is strict. Since we made it as lazy, it did not get evaluated at all. Now it will be evaluated only when you ask for it. As I said earlier, when the lazy expressions gets evaluated only when you ask for it. Dot when I say ask for y, I mean reference that y member of this object. As soon as you reference that y, sorry, why did I say val? Only when you reference that get me the result of y, what is the y, only now it will be created. So that's what we mean by lazy. It will not be evaluated immediately. It will be evaluated only when you ask for the result. Here, this is the Scala language property. This concept is related to the Scala language. In Spark, all the operations that we do will be lazy here. So what I'm trying to say here is, let's say I have val rdd1 is equal to, this is not the 4, 5, 6, 7. And this is not the way to create an RDD. We'll see that later. Just assume that we have an RDD1, which is nothing but a collection. On that, I do RDD1, do some map transformation here. I take each element, and I just say +1. We could also use underscore here. underscore plus 1 we could have done. Now when we do this transformation, nothing gets evaluated. Nothing gets evaluated. It is lazy. You don't get RDD2 at all. Similarly, if I say val RDD3 is equal to RDD2 dot filter with x greater than something like 6. So we get one more RDD, but nothing gets evaluated at all. It is lazy. Similarly, I can say val RDD4 is equal to again some RDD3 dot flatMap and do some transformation. Again RDD5 is equal to RDD4 dot do some sort by. Any operation, I mean not all the operation, we will come to that which operations are lazy and which operations are strict. We will come to see that. But most of the operations are lazy on RDD. Nothing gets evaluated. Nothing gets evaluated only when you ask for the result. What is the final result? RDD5 dot get me the result. I mean, there is nothing called as a method called get me result. There are other methods. When you ask for the result, all these expression gets evaluated. So that's what we mean by lazy. So while it can internally do some optimization, then evaluate all the transformation. So that's the idea of being lazy here. Unnecessarily don't compute and keep the result. Only compute and keep the result when you are asked for the result. That's the one more perspective of looking into lazy. Unnecessarily don't compute and keep the result. Unless somebody asks for the result, only then you evaluate the stuff. That's what we mean by lazy, and RD is a lazy. When we say RD is lazy, the operations done on RD is lazy. We'll see more on this, how the things look like when we actually write the code. So immutable, lazy, and it could be one more thing is cached. Now RDD can be cached. RDD can be cached here. Now what do I mean by caching here? So you after processing the data, your data is represented as a collection now. When you read the data from a file or from a memory, it will be just a collection. Your RDD is a collection. After doing some transformations on that RDD, you get another RDD which is a collection, and that could be again retained in the memory. So that's what we mean by caching. So we can explicitly store this data in the memory. Because of this, we have in-memory processing. After processing the data, we'll get one more RDD. That RDD can be stored can be cached in memory. So that's the reason we are able to do in-memory processing. If the RDD did not, if that collection did not had a caching capability, so we couldn't have the in-memory processing done. So these are the main things we have to keep in mind when we understand RDD. So to summarize this, RDD is just a collection. That's all. Nothing else. RDD is just a collection. This collection is a distributed collection. This collection is a lazy collection. This collection is immutable. This collection is tolerant to data loss. So that's that's what you have to keep in mind when we say RDD is RDD is a data structure of Spark. Means internally Spark represents your data as a collection, and all the operations will be done on the collections. So I hope RDD as a concept, high level concept, was clear here. So this is the theory that we wanted to discuss. The theory is why Spark is required and what is a RDD here. So next what we will do is we will try to check the code here. So I hope most of the people are having this image. As I have shared the image with everybody, so you should be having this image. So you can open the IntelliJ. So IntelliJ will be attached to your panel itself. It is locked to your panel. You can click on that IntelliJ. If it is not available, you can go to the dash home, which is the top icon, the round icon, dash home, then search for IntelliJ. So it should open the IntelliJ. So you should get your IntelliJ opened in this fashion. If at all any of the project is opened already, just say some project is already opened. It will when you open the IntelliJ, that project will also be opened automatically. It will open in this fashion. So just close. If you want to close that, just go to the file tab and close it. Close this and let it be in this form. So search in this, look for Spark core. In this, look for the Spark core examples. So there are certain examples here. So we will be starting with the Spark core first. Starting with Spark core. Now Spark core will learn all the, with the example of Spark core, we'll learn concepts of Spark. Mostly we'll learn the concepts of Spark. So since we want to learn the concepts of Spark, I'm using a older version here. older version as a 1.4. Later I will also have example. I have also have example with Spark 2.x. Also I have the examples. All the, you can use that if you the Spark 2. Experiments. Spark 2. Experiments. It is all based on 2.x. So that you can look into. But to understand the concept of the RDDs and all, we need to understand how the RDD looks like. So that's the reason I'm using a older version. Most of the concepts here, how internal things works, what is the architecture, how the join works, how internal join works, efficiency in the join, different file formats. For all those concepts to understand, we'll be using the older version. And there are examples for Spark 2.x also. I will showcase those as well. Then we'll use this we'll see later. Not immediately, we'll see this later. Spark SQL we have, then we have our Spark string. Now with respect to Spark streaming, there are two streamings here, dstream and structured streaming. Structured streaming is the way to go forward. I will give few examples on structured streaming, but not complete because it is not yet stable. I mean, they don't have APIs to write to other external storage. I mean, as you get the data, you have to save the data. After processing, you can save the data. Using dstream, these are all your streaming. Using dstream, you can save to Cassandra. You can save to HBase. You can save to MongoDB. You can save to Kafka. You can save to most of the S3, HDFS, Hive, anywhere you can save using your dstream. So all those support is not yet available in Spark streaming. I mean to say structured streaming. They only have modified the internal architecture of Spark streaming, but still you cannot read it from somewhere. You cannot write it to somewhere. As of now, the support is only for Kafka and console. External storage support is not yet there from the Spark streaming. So I will just try to explain the few examples, not a real-time example with respect to Spark streaming because there is not yet available any real-time thing happening. So I will explain the real-time applications. The demo that we have seen, if you remember the demo, we did a log analysis. It was done with respect to dstream. It was not done with respect to structure streaming because structure streaming does not support writing to Cassandra, not at no external storage. So first we'll be learning this. First we'll be learning all the concepts. First we'll be doing this, then we'll be doing this, then we'll be doing this. Then I will also show some examples on 2.x. So I hope that will be clear. Now there was a request that to have the session for 1.5 hours. So henceforth we'll be having the sessions for 1.5 hours. So I hope it is fine. Yeah, if anybody has a questions, yeah, I can answer the questions. That should also be fine, Anand. If you are facing any problem, you can just we can have a debugging thing also can be done there. Some things are not working. Right, that would be good actually. If the setup is not working, we can try to do the setup as well.